Hello everyone, welcome to this short video on learning mathematics through concepts and examples. So today we are going to explore limits and continuity using graphs. So here is our first example. Use the graph of g of x. So the graph given here is the graph of the function g of x, okay, in the figure to find the following values or state that they do not exist. So the first one, limit as x approaches to -1 from the left of g of x. In B, we have to find the limit as x approaches to -1 from the right of g of x. And in C, we have to find the limit as x approaches to -1 of g of x. So we are interested all in these three to find the limit, left-hand limit, right-hand limit, and the limit of the function at -1. So what I'm going to do is at -1, I'm just going to draw a vertical line so that it's easy for me to handle this problem easily. Okay, so I've drawn a vertical line passing through -1, which is here. So now the question is, in the first one, limit as x approaches to -1 from the left. When we go closer and closer to -1 from the left, as the way I've shown here with the arrow, you can see that the graph is here. So as x approaches to -1, the graph approaches towards that hole where the corresponding value there is a -1. So as it approaches closer and closer to that hole, as x approaches to -1, function approaches closer and closer to that hole, and the corresponding value for that is a -1. So this is equal to -1. So we can say that the left-hand limit is -1. Now let's look at the right-hand limit. When x approaches to -1 from the right, from this side, when x approaches to -1 from the right, and if you look at the behavior of the graph, you can see that the graph is up here and it is going towards that dot. It is going towards that dot. So when x approaches to -1 from the right, the graph approaches towards that dot whose corresponding value is equal to 2. That means the right-hand limit of that function at -1 is a -2. Is a +2. That's a 2. Now, in part C, we have to find the limit. So from the left-hand limit is -1. From the right, you see that the right-hand limit is 2. The left-hand limit and right-hand limit are not the same. So the limit as x approaches to 1 from both sides does not exist, because for the limit to exist, the left-hand limit and right-hand limit must be equal. Okay, now the next one is, we have to find the x values on the interval from -4 up to 4. Here is -4 and there is 4. So we are looking at that interval from -4 up to 4. So -4 up to 4. Let me just do this so that you can see where I am working on. So I draw the vertical lines. So I'm working on that interval. So I'm working here. I'm checking in that interval from -4 up to 4. Okay, on that interval, we have to find the value of x for which the function is discontinuous, or the function has discontinuity. So you can see that the first discontinuity is here. We have a jump in the function, so that is at -1. So we can say that it is at x equal to -1. And also we have another jump discontinuity here at x equal to 2. Okay, at x equal to 1 and x equal to 2. So function is discontinuous at x equal to -1 and x equal to 2. So this is how we can use the graph to find the limit if exists, and also we'll be able to look at the graph and check if the function is discontinuous on the interval. Okay, here is the second example, which is similar to the first one. Use the graph of f of x. Here is the graph of the function y equal to f of x, okay, in the figure to find the following values or state that they do not exist. So the first one is we have to find the limit as x approaches to 2 from the left, b, limit as x approaches to 2 from the right, and then we have to find the limit as x approaches to 2 from both sides. So here we are looking at x equal to 2. So I'm going to draw a line at 2, so it will make me easy to understand what is going on there. So there's my vertical line at x equal to 2. Now, let's see. When x approaches to 2 from the left, so on the x-axis, you can see when x approaches to 2 from the left, when x approaches to 2 from the left, when you get closer and closer to 2, how is the graph behaving? The graph is increasing and approaching closer and closer to that hole. And the corresponding value for that is 3. So the left-hand limit is 3. Now, if you look at the right-hand limit in B, limit as x approaches to 2 from the right, so from this side, when x approaches to 2 from the right, if you look at the behavior of the graph, you can see that this graph is coming like this and getting closer and closer to that hole whose corresponding value is 3. So that means the right-hand limit is also 3. And for part C, limit as x approaches to 2, that means from both sides, from left side, when x approaches to 2 from left or x approaches to 2 from right, from both sides, the function value is getting closer and closer to 3. So left-hand limit and right-hand limit are equal, so the limit exists in this case, and that is equal to 3. Now, let's go to D. We have to find the x value on the interval from 1 through 4. So in this one, we are looking for the interval from 1 up to 4. So from here, from x equal to 1 to x equal to 4. X equal to 1 to x equal to 4. That is my interval of interest. So I'm just looking here. So in this interval, we have to find the values of x, okay, for which the function has a discontinuity. So we can see that there is a hole in the graph over here. So the function is discontinuous at x equal to 2. Okay, that is at x equal to 2. And also there is a hole here. So the function is discontinuous here. That is also at x equal to 3. And at x equal to 3. So function is discontinuous at x equal to 2 and x equal to 3. Okay, let's look at one more example. So here we have the graph. Okay, below is the graph of f of x, which is given to you. And for the given value of a, so these are the different values of a, we have to complete the table. Okay, so let's see how we can do this. The first one is we have to look at -3. At -3, here is -3. So if you want, you can draw a vertical line there like that. And at -3, let's see. What is the value of the function? So f of a means value of the function at that point. And this one is the left-hand limit. Limit as x approaches to a from the left-hand limit, right-hand limit, the limit of the function, and we have to see whether the function is continuous or not at that point. So here, the left-hand limit, when you go towards this from the left, the function goes there, whose corresponding value is 4. So the left-hand limit is 4. Also, here is a dot. Meaning of that is, because there is a dot, the function value is also 4. The function value is 4. Now let's look at the right-hand limit. If we go from the right towards 3, from this side, you'll see that the graph is going on that direction, down there, whose corresponding value is -2. -2. So the left-hand limit is 4 and right-hand limit is -2. So meaning of that is the left-hand limit and right-hand limit are not equal, so the function is not continuous. I mean, the limit does not exist, okay? So left-hand limit and right-hand limit are not equal, so the limit does not exist. And also, since the function is, I mean, what I mean to say here is, okay, sorry about that. Since the left-hand limit and right-hand limit are not the same, and you can see that the function has a jump here, the function is not continuous. So we say that the function is not continuous, no. Okay, that is at -3. Now the next point we want to see is at 1. So let's see, let me also draw a vertical line at 1 so that it's easy for us to analyze there. Now at 1, the value of the function is here. Here is the dot. That's a 3. Okay, the value of the function over there is 3. Now if you look at the left-hand limit, when you approach 1 from the left, okay, When you approach 1 from the left, you see that the graph is going upward like that. And it is approaching to that hole whose value is 1. And then let's find the limit from the right, because the right hand limit. So when x approaches to 1 from the right, the graph is going closer and closer to that hole there. When it gets closer and closer to the hole, and you can see the value there. So from the right also, the limit is 1. So these two limits are the same. The left hand limit and right hand limit are same. Meaning of that is the limit exists here, and that is also equal to 1. But what you notice is, if you look at the limit of the function and the value of the function, the limit of the function and value of the function are not the same. If the limit of the function and value of the function are not the same, the function is not continuous. So no. Okay, let's look at this point now at x equal to 2. I'm also going to draw the vertical line there at x equal to 2. Okay, so now the first thing we want to look at is the value of the function at a. So if you look at 2, the function is not defined. So you can see that here we have a hole and the function is not defined. So it is undefined. The function is undefined at 2. But if you look at the limit, the left-hand limit, when you approach 2 from the left, the function approaches towards that dot, towards that hole whose value is 1. And also the right-hand limit, when you get closer and closer to 2, the right-hand limit, the function approaches towards that hole again, whose corresponding value is 1. So the right-hand limit is also 1. The left-hand limit is 1, right-hand limit is 1. So since these two are equal, the limit exists and it is equal to 1. But what you see here is the limit of the function is 1, but the value of the function is not there. For the function to be continuous, the value of the limit and value of the function should be same. In this case, we don't have that. So the function is not continuous. No, it is not continuous. Okay, let's go to the next one, the last point here. That is at x equal to 4. So at x equal to 4, let's see what happened. The value of the function. First, the value of the function at 4. At 4, here is a dot. That is the value of the function, whose corresponding value is 5. Now, if you look at the left-hand limit, if you approach 4 from the left, the graph will approach towards that dot, whose corresponding value is 5. So the left-hand limit is 5. Similarly, when x approaches to 4 from the right, the graph approaches towards that dot, whose corresponding value is again 5. So the right-hand limit is 5. And you can see that the left-hand limit and right-hand limit are the same. That means the limit exists and it is equal to this value, 5. So the limit is also 5. And finally, if you look at the limit of the function, that's a 5, and the value of the function, that's also 5. If the limit of the function and value of the function are exactly the same, the function will be continuous at that point. So in this case, yes, the function is continuous at that point. So this is how we can solve the problem involving limits and continuity using the graph. So that's all from this video. Thank you so much for watching. I hope you find this helpful.